9. We did them on the board using lots of different strategies. We know this pattern. We counted on. We used our 10s facts. Sometimes we used our 5s or our 2s if that was easier. And you're filling this in. If we start going across 0, 9, 18, 27, 36, 45 is already there, 54, 63, 72, 81, and 90 is already there. Sean just reminded us that we need to also go up and down on our multiplication chart because we can rearrange those factors. And that number is not going to, that product is not going to change. It will look different. 7, definitely not. But it will not change the total. Gwen. What?
On the bottom, like you just put it, 45 is connected to the 5 and the 9.
Yep, because it is part of our 5 facts and our 9 facts. So depending on which strategy you like, you could use your 9 facts or your 5 facts. Yes? Does that have anything to do with you other than you tattling on Victor? Okay, so can we not do that? Because it's irritating to everyone who's hearing it, and then that just makes it more irritating. Alright, so we're going to continue with our 9s, please. Not our 9s, sorry. We're going to continue with our 3s and 6s. Alright, so on the board said we're going to use counters, but we're not going to use counters. We're just going to draw in our notebooks today, just because we're a little bit behind where I wanted to be, and it's just going to be a little bit easier. Okay? Alright, so we are going to create a 3 by 3 array in our notebook. A full array. Please don't do a fast array. 3 by 3 is not very big. Go ahead and draw that 3 by 3 array in your notebook. Put your crayons up, please, Layden. 3 by 3 array in your notebook. Great. Underneath that, we're going to go ahead and write the equation that matches that picture. What is one equation that matches that picture?
3 times 3.
What is one equation that matches that picture, Sean?
3 times 3.
3 times 3. You can write that underneath or below. Let's go ahead and finish that equation. What is the product of 3 times 3? Jackson?
9.
9. Very good. Underneath that, I want you to create a 3 by 6 array. We're not adding on, we're creating a new array. A new array underneath. 3 by 6 this time. No fast arrays, just full arrays, please. Next to that array, we're going to write the equation that matches it. What equation does match a 3 by 6? Ashlyn? 3 times 6. Go ahead and finish it. What equation? Finish it, Ashlyn. What's the rest of it? What is it? 18, very good. Very good. We have a 3 by 6, which equals 18. How are those arrays similar? How are they similar? Look at them. Can we sit up? How are they similar? Shelby, how are they similar? Shelby said the one on the top is our 3 by 3. And then when I go down to the bottom, it's just 2 of those. Do you see them? Do you see that? Alright, up this side, I want you to write this. I'm going to write down because I'm running out of space. 3 times 3. 3 groups of 3. And then when I add another 3 groups of 3, when I double it, just like we did in number talks this morning, when I double it, this is what I'm doing. I'm adding another 3 groups of 3. So I have 3 groups of 3 plus another 3 groups of 3. And I end up with 6 groups of 3 or 3 groups of 6, however I want to do it. That's a lot of math language happening right there. 3 groups of 3. Alright, if I turn these equations into actual numbers, 3 times 3, that is 9. Plus another 3 times 3, that also is 9. 9 plus 9 equals, what is 6 times 3, which is 18. Well, I'm writing, that means you're writing. We're seeing a lot of those double strategies coming back. If I start with my 3s, I can use those doubles and get to my 6s. Pretty cool. Yes. Oh, let me get on my yellow. Is our 3 times 1. What is 3 times 1?
3.
That's a good question. Victor, what is it? 3. Go ahead and color in 3. 3 times 2. What is 3 times 2? Bella? 6. Color in 6. 3 times 3. Jackson? 9. Color in 9. Now from here, maybe you have your 3s memorized, but let's pretend you don't. What could be a strategy to figure out the next number? If you don't have 3 times 4 memorized, what's going to be our next go-to strategy? 7?
We have 3 and
Uh-huh.
4 and 5 are right, like in the position of like black to 6.
Yep.
And it's like 7 and it gets
Yeah, so Devin, what you're describing is called counting on. We're going to count on by 3, so we would say 1, 2, 3. It's on 12. Sticker?
Couldn't you count by 2s by going to 10? And you count by 8?
So there's 2 missing in between, but we're going to count by 3s because the third one we color. Does that make sense?
I know we're counting by 3.
Oh, okay. Yep. Yep, so there's 2 missing in between. You're exactly right. Alright, what's 3 more from 12? There you go. 15, very good. What's 3 more from 15? Layden?
I was going to say a strategy to do.
Go for it.
Counting on.
That's what we're doing.
Oh.
Yep, 16. So what's 3 more from 15?
18.
18. Will, what's 3 more from 18?
21.
Very good. Harper, what's 3 more from 21?
24.
24. Very good. Finley, what's 3 more from 24?
27.
Very good. All right, I'm going to stop, and you guys keep going. Try to keep your voice off because people are going to be counting on. Go back to that multiplication chart. See what we have left. Because we've got a lot that we have learned so far. Can someone remind me, how do I read a multiplication chart? Like, it just kind of looks like a bunch of numbers. How do I read it? How do I use it is more what I'm asking. Will, how do I use it?
You like take like
Jackson, stop making noise.
if you want to like 7 times 5.
Yep.
To go down until it's next. Then see where it is.
Perfect. Well, I'm just going to add in some vocabulary. So you're going to put one finger on each factor, each part that we're multiplying, and where they meet is going to be our product, aka our answer. So let's start going down. 3 times 0 is 0. 3 times 1 is 3. 3 times 3, that one's empty. What is 3 times 3? 9. Go ahead and fill it in. What about 3 times 4?
12.
12, you can count on if you need to. What about 3 times 5? 15, it's already there. Because we already did our 5. What about y? Does that sound or cube? What about 3 times 6? 18. What about 3 times 7? Count on 3 more. We're at 18. 3 times 6. We need to get to 3 times 7. We need 3 more. What's 3 more from 18, Lincoln? 21. 21. Very good. What's 3 more from 21? Go 3 more than that. 27. Bella? 24. Very good. What about 3 times 9? Elena? Yeah, it's already written. We did our 9s. What about 3 times 10? Ashley? 30. We already did that. It's written. Is there anything else I can fill out on this multiplication? Nope, that's it. That's all I can fill out.
We already did
Michael?
You can fill it across this one
Why? How can I do that?
because it is music.
What does that say? What is that special rule that is? It's not going to be the same thing.
The same
Same total. Very good. That's important, guys. It is not the exact same thing. Please stop making noise, Jackson. The amount, the total amount will be the same, but 4 times 3 looks different than 3 times 4. It's not the exact same thing. It's just the exact same total. Alright, so we have 0, 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. Whoa! We have a lot filled in. With all those math facts, you guys have learned some strategies to solve. Please don't make noise, Frida. I'm going to try and solve 6 times 6, but I'm going to use 3 times 6 to help me. What is 3 times 6? What is 3 times 6, Gwen? 3 times 6 is 18. We did write it in our notebook. That announcement's not particularly helpful, though. 3 times 6 is 18. How do I use this fact to help me get here? How do I use that 3 fact to get me to 6's? Because I'm not actually trying to figure out 3 times 6. I want to figure out 6 times 6. Will, sit up, please. Sladen?
You could double it.
What is 18 double?
36.
I can double it. I would have 3 groups of 6 plus another, 3 groups of 6. 18 plus 18.
If you have so you have the 10 and the 18.
Uh-huh.
You double that, but then you double 16 plus 16.
You have 8 plus 8 to get to 16.
Then you have 20.
Okay. Did we draw circles and dots?
No.
Could you?
Yeah.
Yeah. This is just doing it another way, in a way that you could do it in your head. Circles and dots in your head would be really challenging. But being able to use our doubles, we could do that in our head. Let's try one more.
Or
How about 6 times 9?
Okay.
6 times 9. I want you to try and solve it with your 3.
Okay.
When you figured out what is 6 times 9, give me that secret sum. Alright, I see some hands. How'd you do it? How'd you do it? Jackson, how did you do it? I don't have 6 times 9 on the board. Oh, I do have 6 times 9 on the board. But how could I do it with my 3? Because that was the direction.
So we just get rid of the 6, get rid of the 3 from the 6, and then like that, and then
What is 3 times 9? 27. Okay, keep going. You're on the right track.
and then plus another 3 from the 27, and that would be the answer.
What is it?
56.
56. I can just double this, and I have my 6s.
Wait, you do have it on the board?
Do I have that exact equation on the board?
No.
No. What does Jackson mean when he said, well, you have it on the board? I don't have 6 times 9 on the board. I don't have 6 times 9 on the board. Harper, what's happening? What was Jackson using?
9 and 6.
Is that allowed? Can he do that?
Yes.
But does it look the same?
It doesn't matter.
It doesn't matter.
I think I know why.
But
Because if you switch it around, you're adding 2 to it.
Nope, I'm not adding 2 to it. Bella?
Ooh.
Not the same thing.
You know it.
It's just a language thing. It's not the same thing. Shelby? It's not going to equal the same thing. Our language piece. John?
Because he's using commutative property.
Which says what?
It is, even though it looks different, it still has the exact same answer.
Same answer is fine. Same total, yes. But it's not the same thing. 9 groups of 6 is different than 6 groups of 9. That is different. I would draw that differently. But the answer, my total, is the same. So we don't want to say that it's the same thing. We could say same total, same answer, same value. It's worth the same amount. But it is not the exact same thing. Put those up, please. Yes, ma'am. Oh, it's 54. Sorry, that was my dad. I was doing too many 6s. It's 54. Great. I'm glad you figured it out. All right. So let's turn back to those hundreds charts. This time you're going to get out a blue. And we're going to color our 6s this time. We're going to color our 6s this time. We're right on the last one we just did. You don't need to turn very far. Alright, now I just learned, Logan, that our 6s were the doubles of 3. So watch this trick. I know I'm not going to color 3 because 6 times 1 is already bigger than that. I'm going to go ahead and color my 6. And then because it's double, I'm going to skip the next 3 and go to the second one. Skip. Go to the second one. Skip. go to the second one, because when I double, I don't hit every single 3. I hit every other 3. Yes, ma'am. Okay, problem solved. Thank you for solving that problem.
You're always skipping one number?
I'm always skipping one multiple of 3 because I am doubling. I'm doing every other one. Jackson, why don't you go a little slower, because I see we're skipping some numbers on accident. Could I count on by 6s? Could I count on by 6s?
Yes.
Yeah. If that works better for your brain and you would rather just count on by 6 every time, go for it. Go for it. I'll give you some seconds to get all the way through. So on the next blank page, this is our last strategy we're going to use for 6s. How else could I solve our 6s? That's the title on the next blank page. We just learned I could double my 3s, which is a really good strategy if I'm good at my 3s. You know who's not good at her 3s? Miss Miller. So that's not my favorite strategy. But if you're good at your 3s and you can double them really quick, go for it. I love that. But this is my favorite strategy because this is the strategy that works for my brain. Nope. Nope, you can't sharpen the pencils right now. You have one time to sharpen the pencils. It's at the end of the day. So just find one that'll work for you for now, okay? Strategy, what I call it, is break apart.
Oh, I've done that.
You have used break apart strategy to add before. Gwen did it earlier. When she was adding 9, she said I added 2 first and then I added 7. She just broke that 9 into 2 easier parts for her brain. You can use that same strategy to multiply. You can. I'm about to show you how because it's my favorite. So let's pretend I have this fact. 6 times 7. It's pretty large. If I was good at my 3s and I knew 3 times 7, I could double it and be done. But that's not my go-to strategy. So instead, I'm going to break apart my groups, kind of like how we did, remember when we did 10s? And we took away one group?
Yes.
So what we're going to do today is we're going to take our 6 groups and I'm going to separate them into a 5 group and a 1 group. So if I was drawing a picture of this and I had my 6 groups of 7, 1, 2, 3, 4, 5, 6. There's my 6 groups of 7. All I have done is basically put a wall there. You know when you're on when you go to the grocery store and you put your groceries on the little conveyor belt and they have those sticks where you can put them to separate your groceries?
Yeah.
I just put a stick separating 5 groups of 7 on one side and 1 group of 7 on the other. Yeah. Okay, so far so good?
Yes.
Not anything crazy? Alright, so now what I'm going to do is I'm going to solve this in the easier parts. Because for me, solving 5 groups of 7, I can skip count that so good. This right here is this part. 5 groups of 7. What is 5 groups of 7? Actually, I'm not going to write that right there. I love Michael just whipped out those skip count fingers so fast. 5 groups of 7, you can do it. There's 5 groups of 7. 7, 35. But it's 5 groups of it's 5 groups of 7 what I'm trying to find.
No.
No.
No, I still have that lonely group of 7 that I picked out. So I need to add that lonely 1 group of 7 back. What is 1 group of 7? What is the
7.
answer to that?
7.
Gwen, what is it? 7. Then I can do 35 plus 7. What is 35 plus 7? Elena? 42. Was that way easier?
Than a normal? Yeah. Like if we just
Like, could you imagine if you had to count all of those sevens?
That's it. It would probably take the whole school day.
6 times 7 is 42.
6, 7.
I like break apart because I can take something hard like my sixes that I don't skip count well, and I can make it easier. I know my fives and I know my ones. That's way easier for me to multiply with than my sixes.
And it's also easier because if you were counting them, you would probably lose track.
Yeah, for sure. For sure. So we figured out 6 times 7 using break apart. Let's go ahead and do 6 times 6. So find a new spot. Let's do 6 times 6. We're going to use that break apart strategy again.
6 times 6. What if we already know this?
So I'm going to break apart 6. Even if you know the answer, it's good practice because you can use break apart for any number. We're just using it for 6s because that's what we're doing right now. But you could do it for 17s. You could do it for 9s. You could do it for 100s. You can use this strategy for any math fact.
Are we going to be maybe using it for like higher grades? Like
100%. So I'm going to break apart my 6 into 5 and 1. Could I break apart it into something else? I can do 2 and 4. 2s are easy for me, but 4s are not easy for me. So I don't choose to do 2 and 4. But if you know 2s and 4s, could you break it into 2 and 4? I don't recommend breaking it into more than 2 numbers when mathematically, yes, you can. But then it starts getting complicated to keep track of all those numbers. Okay?
If you do 7, 5, and 8.
I like to break it into 5s and 1s because 5s and 1s are easy, and I like easy. Nod your head if you like easy. All right, Tinley, let's go. We got 5 groups of 6. What is 5 groups of 6? What is that worth?
5 groups of easy. Oh, yours minus 6.37.
What you counting? I see your fingers moving. What are you counting? Huh? We're not counting 6 groups of 6. I want to know 5 groups of 6.
Can I give her a...
Nope. She's got it. What are you counting? How are you counting it? Are you counting by ones? Okay, could you skip count by one of those numbers? Which one? You can skip count by 6s? Do you know how to skip count by 6s? Do you? Okay, so what about the other number? Can you skip count by 5s? How many skip counts of 5 are we going to do? Then do it. Yep. Another way to do that, Finley, instead of using our fingers to show groups of 5, I'm going to keep the 5 in my head, and I'm going to hold up each group. So this is one group of 5. 5, 10, 15, 20, 25, 30. So I'm counting groups, not the individual pieces. Does that make sense? Yeah. 5 groups of 6 is 30. Wait, is that what I was solving, though?
No.
No! I need that leftover 1 plus one group of 6. Remember, if I'm writing, that means that you are writing, please. What is one group of 6? That's not hard. I know we know that. Michael? What is that total?
36.
36. 36. This strategy you can use with any math fact. Awesome. So you can use it with any math fact. We just focused on sixes because that's what we were working with today, but you could do it with anything. With anything. So what we're going to do is we are going to wrap up by filling in our mini multiplication chart way back at the beginning.
And it's dog here.
We have lots filled in. There's not a whole lot left on our sixes to fill in. What's one math fact on our sixes that we have to fill in? Use your fingers to help you. What's one math fact that I need to fill in on my sixes? Not one that I've already filled in, one that's empty. So I should see fingers to figure out which ones are empty. What equations are empty on my multiplication chart. Jackson, please stop making noise. So we're looking at that multiplication chart. I see Will's using his fingers to figure out which equations are empty. That's what I'm trying to figure out. Which ones do I not know yet? Shelby, which one do I not know? What is it? Are we doing fours today? So did I not fill in our fours? Oh, we'll have to go back and do that. But right now we're going to talk about sixes. What six facts have I not filled in yet? Lincoln?
6 times 6.
I have not filled in 6 times 6. We just did that. What is the product of 6 times 6? We just solved it in our notebook. What was that product? Lincoln's looking. What was it, Lincoln? 36. Let's go ahead and fill that in. What are some other facts that I need to fill in that I haven't yet, Sean?
6 times 4.
6 times 4. What is 6 times 4?
24.
It is 24. What about 6 times 7? 6 times 7. Michael? 42. 42, we did that one. Last one is 6 times 8. 5 times 8 is 40. 1 times 8 is 8. Add those products together. 40 plus 8 gives me
48.
when? 48.
No.
48. Anything else I can fill out on my multiplication chart? Anything else I can fill out? Harper? With sixes, please. Nope, I'm all done with my sixes. Nothing else I can fill out. Ashley? I can fill in the sixes going straight down. Why? Why? Why can I fill out the sixes going down? You're right, I can, but why? Tell me why. Okay. When?
Multiplication, so we can use computer property and flip things.
When I flip things around, does that change my answer?
No.
No. Does it look different when I flip them around?
Yeah.
Yeah. Looks different, smells different, tastes different, feels different, but it gives me the same total. So let's go up and down. I have 6 times 4. We just figured out that's 24. 6 times 7. We have that answer. It's 42. And then 6 times 8 is 48. You already have those answers. You don't need to see the board. You already wrote them in your notebook once. You already wrote them in your notebook once. Alright, if you want to, not if you want, go ahead and take some seconds to add in those 4s. We're only missing 5 4 facts. You can count on with your 4s to figure out those missing 4 facts. And once you are finished filling in your 4s, you can move on to your math choice board from this week. Gwen?
When we put in the 4s, is there supposed to be only 4 boxes?